Know this by now, you're in trouble. Okay, here we go. Ready? So Justin, this Justin here. What's the input into sine? What's the quantity that's the input into sine? Angle swept counterclockwise from 3 o'clock. And then what's the output? Nathan? In? Radius lengths, right? Okay, so we learned something. Okay, we've learned something. So now we're going to talk about what would it mean to reverse that process? Reverse that process. If we reverse that process, then what would we have this notation, right? We've talked about that back in September. This notation means reverse the process of f. So if we reverse this process of f, then what is the input? What would the input be? Austin? So what would it be? What quantity would be the input if we reverse the process of the sine function? What would we be putting into that? Horizontal distance. See what's horizontal distance? Jonathan, what do you think? Vertical distance. So now our input in the reverse process will be vertical distance above the horizontal diameter in radius lengths. And what will the output be? Fernando? Yeah, so that reverse process then will give us the angle. So given a vertical distance in radius lengths, it'll give us the angle swept counterclockwise in radians. Okay? So there's that. So let's kind of give this a shot here. So now oh jeez. Look at that diagram down there below. And I'm showing by the red horizontal line then, I'm showing vertical distance above horizontal diameter. Maybe. And so now this becomes our input. If it's positive, we're up above, right? And if it's negative, we're down below. Okay? So now I want you to then interpret the meaning of each notation and then solve it or find the value. So interpret the meaning and find the value. Work together, talk it out. So first interpret. So what does it mean? What does the 1 mean? What does the whole thing mean? And then find the value. What does the 0 mean? What does the whole thing mean? Find the value. Okay? Go. Good shot. Okay, ready? See how we did. So see here. Cujo. What does the 1 mean? Nice and loud. Vertical distance in radius lengths, because that's the input of the reverse process. And keep going. What is the whole thing? Angle swept. Okay, so that situation is represented by here. If we put the input at 1 radius length above the horizontal diameter. So I'm showing it with that red line there. And so what is the angle? What is the output of this process? Cujo. Okay, how about radians? What your radians is? Oh, we work so hard on radians. Yeah, pi over 2. Agree with that? Comments? Okay, how about this one? What does the 0 represent? What is it? When y is at 0, the vertical distance is at 0. Okay, so then what does the whole thing represent? Keep going. And what quantity would that be? What's that? So the output of the reverse is, he said pi. Angle swept counterclockwise. Or 2 pi. Or 0. Or, any more? How about 3 pi? How about negative pi? What's happening here? So if you pick a vertical distance, in this case right here at 0, not doing a good job showing that. That's the best I can do. So picking that vertical distance to be 0. Look over here. This is our sine graph over to the right. What is it showing about the angle that's the output of that process? How many are there? Yeah, we can keep adding, you can just keep going around the circle, adding more and more angle measure. Every time we hit the 0 vertical distance, which is every time we add pi, we're going to get an angle that gives us this vertical distance. What about radical 3 over 2? So here's y equals radical 3 over 2. If we input that vertical distance into the reverse process, what will it give us? Yeah, Taylor.
It will give us the rad 3 over 2 is the vertical distance from the horizontal.
Right.
It will give us the angle split from our counterclockwise from the 0.
Good. And which particular angle would it be for that vertical distance?
Pi over 3.
He wants pi over 3. Agree with that? Any more to say? Okay, so pi over 3 is that's pi over 3. 2 pi over 3. What do we think? 2 pi over 3. Again, look at the graph on the right. How many? So over here, now we're saying the input is this y coordinate, and our output of a reverse process will be x coordinates. Every single angle that gives us that vertical distance of radical 3 over 2. How many are there? Just 2. There's just 2 angles that will give us that vertical distance of radical 3 over 2. Is that right? Faisal, why infinite? Yeah, so we don't have to stop at 2 pi, right? We can keep increasing that angle. Every time we go around the circle, 4 pi, 6 pi. Every time we go around the circle, when we hit this spot on the circle, we get that vertical distance, and same with that spot. And so that's what that's showing here. Here's pi over 3, 2 pi over 3. And then this is 2 pi plus pi over 3, and 2 pi plus 2 pi over 3. And then 4 pi plus pi over 3, 4 pi. See? So every time we go around and make a full rotation, then add another pi over 3, that's an angle that'll give us that. Okay, so what about this reverse process? Is this reverse process a function? Put in a vertical distance. Is it a function?
Yes.
Yes, it is. What are functions? Sometimes you call, when you dial, you want to dial Domino's Pizza. Sometimes you get your mom. Sometimes you get your ex. Sometimes you get the phone company. Is this a functioning phone? No, every time you dial a number, you want to get the predicted, determined person on the other end. That's a functioning phone. Okay? So what about this? Is it a function? No, it's not a function. Sine is a function. For every angle, there's only one vertical distance that you get. But when we reverse that process and we pick a vertical distance, well, now there's lots of angles that will take us into the point in the circle that gives us that vertical distance, right? So, as it stands, we don't have a function. But we want a function, okay? So what do we have to do to get a function here? What do we have to do? We have to decide on just a particular, over here, some particular range of angles. Okay, so we need one continuous interval of the angle theta so that every possible input value, what are our possible input values? From what to what? What are our possible input values? From what to what? 0 to 1. Like that, 0 to 1. Those are all the possible inputs for vertical distance? Negative 1 to 1. Those are our possible. So for every one of those input values, we need to get exactly one angle in the interval that we pick. So we want to be strategic about picking an interval of angles so that every single input or every single vertical distance gets mapped to exactly one angle. So any suggestions? How can we do that? So we want to take just a piece of this so that that red line doesn't cross, only crosses the graph once. Only crosses the graph once and gives us one angle for the given vertical distance. Yeah? What's that? One revolution. Will it do it? So here we go. Good suggestion. Let's try that. So he wants one, which we want to just take the interval of angles, say from 0 to 2 pi. We're just going to take what I've highlighted in blue, and will that give us one output angle for every input y coordinate? Does it work? Look at the blue part of the graph. Does it give us one angle for every one y coordinate? No, it doubles, right? So here at see, for this particular y coordinate, I'm getting an angle here and also here. So I get two. I get two angles, or in other words, this angle and this angle. So doing the whole period from 0 to 2 pi doesn't work. We still have the same problem. What is it again? He said negative pi over 2 to positive pi over 2. So what is a negative angle? We got to make sure we got that. What does a negative angle represent in terms of if we're counterclockwise as our positive angles? Then what would a negative angle be? Yeah.
The angles clockwise.
Yeah, so if we go clockwise, that's how we get negative angles. So he's suggesting from negative pi over 2, start down here at negative pi over 2, and go to pi over 2. What about that? Does it work? So you just imagine the graph from here to here, or from here to here. So if we only had that much of the graph, for any y coordinate that I chose, would I just get one angle? No matter if I chose anything from -1 to 1, does it give me one angle out?
Yes.
That works nice. And the nice thing about it is when that input is 0, meaning 0 vertical distance, what angle do we get for this? What angle does that range of values give us for a 0 y distance? What angle is this right here, guys? 0. 0 right there, 3 o'clock position, 0. So this is the most convenient choice, and this is what mathematicians, okay, watch this, ready? Here we go, don't miss it. So this is what mathematicians have decided long ago would be our range of angles to get us to make this reverse process a function. So that for every value that you pick from -1 to 1, the y-coordinate maps or points to just one angle. Okay, so this is for the reverse process. This is the possible output angles. Starting at a negative angle of, so negative angles here are swept clockwise. So starting at -π/2 when the vertical distance is -1, and then sweeping counterclockwise from there. Then our positive angles in the first quadrant when the y-coordinate goes from 0 to 1. So the input of the reverse process is vertical distance above horizontal diameter. The output is the corresponding angle that's between -π/2 and π/2. So now we have a function. And this is exactly what your calculator does. When you use the inverse process of sine, what we call the arcsine, it does this very thing, okay? It's going to only output one number. All right, so let's talk about the reverse process. What is the domain? What are all possible inputs? So I want you guys, talk about that. Just take 30 seconds. Review. What's the domain of the inverse sine? And what's the range? Meaning, what are all possible input values? And what are all possible output values? Okay, let's see what you thought. Adam, what about the domain of this reverse process? So what's the least to the greatest that we can, what's the range of input values we can put into this function? Yeah, Adam. Okay, so we're talking about all possible inputs. Is the angle the input into this function? What's the input? Right, -1 to 1. Okay, again, reverse process. The input is the y-coordinate, or the vertical distance above horizontal diameter in radius lengths. So the least is -1, the greatest is 1. Range, Jackson.
The range is going to be anywhere from
-π/2 to π/2. Because the output is what kind of value?
The angle swept counterclockwise.
Right, angle swept counterclockwise. When we sweep clockwise, we get those fourth quadrant angles as negative angles. Okay? And so it's like starting over here at negative pi over 2. Does this make sense? So you have to have this, so this construct of arcsine. Oh, and then here's the notation. There's two different ways to express it. Arcsine is one way. So we see arcsine of x, that's this reverse process of sine. Also, we call this sine inverse, so with the -1 exponent, but it does not mean 1 over sine. It does not mean 1 over sine. It means the reverse process of sine. Okay, any questions? So understanding what's going on here is crucial. When you get into these problems and you're punching numbers in your calculator, you've got to know what the calculator is telling you. And we'll see some examples later in class where you'll get my drift. You'll understand my point, that you really have to know what's going on to interpret those values. So let's practice here. So here I'm giving you an expression, the arcsine of the sine of 3 pi over 4. So 3 pi over 4 is the angle. We put it into sine, and what comes out of sine? Vertical distance, or y-coordinate, right? And we're going to take that vertical distance, or that y-coordinate, and we're going to put it into arcsine. It's going to reverse the process. So what's the answer going to be? 3 pi over 4, right? Not right. Let's do it. What is the sine of 3 pi over 4? Did you retain your unit circle quiz info? Sine of 3 pi over 4. Rad 2 over 2. So that angle is 3 pi over 4 is here, splitting the second quadrant. There's 3 pi over 4. Rad 2 over 2. So that's just the input into arcsine. That answer is radical 2 over 2. So I'm going to put that as our input into arcsine here. Right there. Now, we're going to put that vertical distance above horizontal diameter into arcsine. Is it going to give us 3 pi over 4? No, it's going to give us an angle between negative pi over 2 and pi over 2. It's going to give us that one angle between negative pi over 2 and pi over 2 that has this vertical distance of radical 2 over 2, which is? Some of you said it. Pi over 4. Do you see what happened? So these are nice little problems to see if you understand what's going on, okay? So the sine of 3 pi over 4 is radical 2 over 2. That's this height right here. Now when you put that through the reverse process, our arcsine, the way it's defined, it's going to give us not 3 pi over 4, but the angle that has that same vertical distance in our range of negative pi over 2 to pi over 2, which is pi over 4, right there, where I pointed the arrow. Okay, so while I take roll, you've got four others to work on there. So go slow, talk them out. See if you can figure these out, okay? Okay, sine of 5 pi over 3. Kiko. Just the sine of 5 pi over 3. Negative radical 3 over 2. Is that what you got? That's just this part. And then what's the arcsine of that? Morgan. 4 pi over 3. Is that in our range for the output of arcsine? Four pi over 3 is this angle here. So we need the angle. So let me show it here. Negative radical 3 over 2 is like this. So 5 pi over 3 then is this angle here. That's 5 pi over 3. So we get the output of negative radical 3 over 2, and then we put that into arcsine, and it gives us what angle? Negative pi over 3. Agree with that? Does this make sense? That's right, negative pi over 3. I'll stop for questions. Is this making sense? Really, this is great questions to see if you understand arcsine. Any questions? All right, I'll take a request on the remaining 3. Which one do you want me to do? Request. Negative pi over 4. Okay? What's the sine of negative pi over 4? What's that? Negative root 2 over 2. And so that's this input right here. So what angle between negative pi over 2 and pi over 2 has a y-coordinate of negative radical 2 over 2? Negative pi over 4. Did you get it? So the answer to this one is truly negative. So sometimes, if your initial angle is in that range, from negative pi over 2 to pi over 2, you put it through both processes, it will truly give you back that angle you started with. So the answer to that one is negative pi over 4. Are we good? Questions? Okay, so what about arc cosine? What about arc cosine? So in the arc cosine, the reverse process of sine, while I'm changing up my screen, I want you to talk to the person next to you about that reverse process of cosine. What will be the input? What will be the output of the reverse process of cosine? Go. Okay, Moises. Input of the reverse process of cosine, what will we put in?
It'd be the distance to the right in terms of radius.
The distance to the right in terms of radius lengths. Right. The x-coordinate now is going to be the input in radius lengths into the reverse process. And what will the output be?
It'd be decrease in radius, counterclockwise from 3 o'clock.
Angle swept counterclockwise from 3 o'clock will be the output of that reverse process of cosine. So we have the same issue here. If we pick an x-coordinate, so remember that the x-coordinates, or those horizontal distances on the cosine graph, are shown on the vertical axis, right? So you see that as I move that, it's really showing it over there as the vertical axis, because our horizontal axis is angle. So we have the same issue. So for this particular, for negative 0.5, as our input value, how many angles do we get that give us that horizontal distance? How many angles do we get? An infinite number. We can just keep adding more and more angle measure, keep increasing the radian measure, and every time we get to this point in the circle, we're going to get the the x-coordinate as -1/2. And so you just see every intersection here is giving an input angle, an angle that would be coming out of the reverse process of cosine. So again, we need to restrict, we need to take a piece, one piece of the cosine graph, so that we get a continuous interval of angle such that every possible input or every possible x-coordinate that we put in will map to or will assign one particular angle. So I'm going to let you talk for a sec and see if you can determine what interval of angle, what piece of this graph over here will just give one angle output for each input x-coordinate that we could pick. Okay? So see if you can figure it out. Go, talk about it. There's a best choice. There's a best choice. Let's see. McLean, what do you think? The top half, are you looking at the right graph or the left graph? You want the top half of the circle. So what would be the most convenient interval of angle that would get us the top half of the circle? You want 0 to pi. All right, watch. The best part of the class right here, ready? Ooh. Right? He's right. We want the top half of the circle. Because we want an interval of angles such that every input from what? What's our possible inputs? From what to what? -1 to 1 are our possible inputs. So for any input that we choose, we want to get just one angle. And so we pick the top half of the circle, or over here, the interval from 0 to pi gets us just one angle for every x-coordinate from -1 to 1. Okay? So you practice. So same thing. We call that function Arccosine. Now that it's a function, now that we've restricted that angle to actually make it a function, one output for every input, we call it the Arccosine function. Or this over here on the right, the inverse cosine. All right, so the domain is all possible values from -1 to 1, horizontal distances and radius lengths. Output is some angle between 0 and pi. Practice, go. Okay, Andrew, cosine 4 pi over 3. Just this much right here. Remember what that is? Negative 1/2. Agree with that? That's about where I've got it right now. So this angle right here, that's our 4 pi over 3. The cosine is the horizontal distance in radius lengths, negative 0.5. So now, when we put negative 1/2 into the arc cosine, what are we going to get? Who said that? G? He says 2 pi over 3. Agree with that? So now what we're talking about is which angle between 0 and pi gives us that same x-coordinate. This angle right here, 2 pi over 3. Questions? Does this make sense? Okay, cool. Then Leah, you do the next one. Tell me, what's cosine of 7 pi over 4? Positive or negative? Positive radical 2 over 2. Show that. That's this angle right here. That's 7 pi over 4. And so she's got a x-coordinate of positive radical 2 over 2. And so therefore, our cosine of that x-coordinate, Leah, pi over 4. Are you following this? Last one. Volunteer. Cosine of negative 7 pi over 6. Yeah, Ryan.
So it would be negative square root of 3 over 2, and then that's the same as 5 pi over 6.
Okay, so I'm going to draw that angle, negative 7 pi over 6. Negative 7 pi over 6 would be yep. But negative 7 pi over 6 would be this angle right here. And you said, so that cosine is what? Negative square root of 3 over 2. And now, what's the arc cosine of that? In other words, what's this angle, the angle between 0 and pi? 5 pi over 6. Okay, so now we're going to do some practice, some more application problems, and you'll see why knowing all this stuff is crucially important for when you start using your calculator to solve problems, okay? Last chance for questions. Okay, so remember Mr. Bug on the fan. So here I'm showing the fan has a radius of the fan has a radius of 2.3 feet. Okay? Fan radius is 2.3 feet. Currently, so the bug has started his journey, and currently he is 1 foot above the horizontal diameter. He's 1 foot up. And the question is, what angle has the fan swept from counterclockwise in the 3 o'clock position? So what do we have? We have vertical distance. We want angle. What process or relationship, if we have vertical distance, will give us angle? What relationship can we draw from our tool bag? You said arcsine. Is the input to arcsine a vertical distance? And the out, some are shaking their head, some are nodding. What's the input into Arcsine? Vertical distance above the horizontal diameter. What's the output? Angle, okay? So, we're going to use Arcsine, but what's the units into Arcsine? Radius lengths. Can we put 1 foot in there? No. How many radius lengths are we above? That's what we need to put in there. So what fraction of a radius, or how many radius lengths? 1 over 2.3. Okay, so find that value in your calculator. So you're going to go second sine, and then parentheses 1 over 2.3. And we're going to see, this is going to give us an angle. The angle that it gives us will be between what? What and what? 0 and 1. The angle will be between 0 and 1. Agree with that? Negative pi over 2 and pi over 2. So I think is it 0.45? How about one more decimal place? 0?
Yeah.
Perfect. What does that number mean? 0.450. Can you interpret? Is that the angle we want?
Yes.
Is that the answer to our question? What is that? Is that a number of feet? Is that a number of radius lengths? Is that degrees? Is that radians? What is this number, and what does it mean in our context here? How about to start with the units? What are the units on this? I heard radius lengths. It's not radius lengths. Radians. It's the angle. What quadrant is an angle of 0.45 radians in? First quadrant. Half. It's almost half a radian, right? Almost half a radian is over here. Radians are openness. Radius length is distance. But yeah, it's the same value. Same value. Okay, so here we got 0.45 radians. So how does it relate to our problem? I thought we wanted this angle. How are we going to get that? So what we just found was this angle right here. This is 0.45 radians. Why? It's the angle that has the same vertical height as our bug. So I didn't really draw it too well, actually. Just getting messy. That should be the same height as, there we go. Okay, so it's the angle that has the same vertical height as our bug, but in the range from negative pi over 2 to pi over 2. So how are we going to find the angle we want swept from 3 o'clock, this one? Any ideas? Yeah, Taylor.
The Arcsine or Sine of 0.450.
That's just going to give us right back to 0.45. How are we going to get this angle from this one? Anyone see it? Yeah, Shruti. Pi minus 0.45. Is that, there was another hand up here. Yeah, so what you have to recognize is that angle there then is the same as this angle here. That's also 0.45 radians right there. And so we're going to go pi and then go back 0.45 radians. So now find that, find that value. What's that? What is it? Does that seem about right? 2.69 radians based on where the bug is. Yeah. We know 3 radians is almost halfway. So 2.69 radians. Makes sense. Okay, so what's the moral of the story? When you start using your calculator to solve for these angles, you got to know what the calculator is telling you. You have to understand arc cosine and arc sine really well. Okay, next homework is due Wednesday. Have a good weekend.